Have you ever seen a toddler learning how to walk, taking wobbly steps, then suddenly figuring out how to move around more smoothly? That's kind of what's happening today in the world of AI. A brand new large language model called DeepSeek R1 has just arrived, and it's making big waves, just like a baby who finally learns how to walk without falling over. In this video, I'm going to simplify it down for you and make it easier to understand. DeepSeek R1's model, developed by an AI research team from China, performs at a similar level to OpenAI's O1 or Claude Sonnet 3.5 on tasks like math, coding, or scientific reasoning, and according to benchmarks, has already outperformed some of the top models at a fraction of the cost. In this video, we're going to take a simple look at the three main ideas from DeepSeek R1's research paper. Chain of thought, how the model thinks out loud and corrects itself. Reinforcement learning, how the model learns in trying and improving. And model distillation, how a big model teaches a smaller one to be just as good. The first idea is chain of thought. It's like asking your friend to show their work when solving a math problem. Instead of just telling you the answer, the model explains how it got there. This way, if it makes a mistake, we can easily see what happened and where it went wrong and how to fix just that part. In the example from the paper, the model might say, let's see 2 plus 3 equals 5. But wait, let me double check that step. It's basically just thinking out loud and seeing what it's doing. By showing its reasoning, DeepSeek can catch errors more easily and learn how to correct them on its own rather than having intervention from one of us, leading to better answers overall. The second idea is reinforcement learning. It's just like a toddler figuring out how to walk. They stumble around and try different ways to move. Each time they succeed, it feels like a reward, so they remember what worked. Each time they fall, they learn what not to do next time. DeepSeek R1 uses reinforcement learning in a similar way. Instead of giving the model the correct answer right away, it explores different ways to solve the problem. We measure how accurate or helpful the answer is, and then the model adjusts its policy or way of thinking to get higher rewards and better answers. Over time, it becomes more accurate and can outperform a static model like OpenAI's O1. If we keep letting DeepSeek R1 train itself this way, it could get closer and closer to 100% accuracy, especially on tricky tasks like math or coding problems. While learning, the model also uses chain of thought to review its own steps and seeing where it went right or wrong. This keeps it on track to improve steadily instead of jumping all over the place. A little bonus, the secret sauce behind how DeepSeek's reinforcement learning is something called Group Relative Policy Optimization, or GRPO. That's a fancy term, but here's the basic idea. We compare the model's old answers to its new answers. We reward the model when its new answers are better and gently push it to change in small, stable steps so it doesn't get confused and forget everything it learned before. We also add little penalties to keep the changes steady and prevent wild swings. Think of it like teaching your child how to walk. You don't suddenly strap them into roller skates on day 2. You make small improvements, encourage them gently, and keep them from falling too hard. Finally, the third idea, let's talk about model distillation, which is a fancy way of saying the big model teaches the smaller models how to do the same trick. DeepSeek R1 is huge. It has over 670 billion parameters. Running it takes a lot of computer power. To make it more accessible, the team has created smaller versions, like ones based on Llama 3 or Quen, and the big model generates lots of examples with chain of thought reasoning and shows the smaller ones how to solve its problems. The smaller model learns from these examples and ends up being almost as good as the giant one, but uses far less resources. Surprisingly, these models sometimes even surpass the teacher model in certain tasks, all while being cheaper to run. And that's just DeepSeek R1 in a nutshell. It uses chain of thought to help it think out loud and refine its answers step by step. It uses reinforcement learning to learn by trial and reward, just like a toddler figuring out how to walk for the first time. And it uses model distillation, which spreads the knowledge from the giant models to the smaller ones, making the AI world more accessible to everyone. If you'd like to learn more, check out the paper linked in the description. You can also try DeepSeek R1 online, and you can see how it tackles math, coding, and science questions yourself. Thanks for watching. See you in the next video.